Hey everybody, Dr. A here, and in this video we're going to be exploring an example of sketching the free body diagram for a 2D rigid body. So let's go ahead and get started. In the given information, we're being asked to sketch the free body diagram of member ABC. So let's take a look at what we have here. First, we have this member ABC, which is really this L-shaped member here, this kind of inverted L-shaped member. So we have point A here. Point B is supported by a roller here, and then we have point C here, which is another internal hinge, okay? Now, point A has the member pinned to a smooth collar. So we see this rectangular block right here is the smooth collar, and that smooth collar is allowed to slide or translate on this shaft, okay? Now, because we see this little pin here, this little black dot, that also indicates that this member could rotate here as well, all right? Now, point B is a roller. We're pretty familiar with those by now. And point C is another smooth pin, which is connecting the L-shaped member to a link, kind of a short link CD, that is then finally pin connected to a point D. But again, what we're really interested in is this inverted L shape, okay? So let's go ahead and sketch that out. If we start with writing solution, the free body diagram of this is just going to be that inverted shape, okay? So it's going to look something like this as like a line drawing, okay? And we're going to have the known load P here. And we have the dimension lines here, L and L. And we have this dimension line, 0.7L. So again, this at first glance, this figure looks kind of complicated, but if we just break it down to, the simplest form we can break it down to, which is this sideways L shape, it's really not that complicated anymore. So we're going to have a force develop here. We can call this FA. Now, FA is going to develop normal to the angle that this shaft is at, okay? So we're going to have this force here develop FA, and that's shown here. Now, at the roller B, we're going to have a BY develop normal or perpendicular to the surface that the roller is sitting on. And then finally, we're going to have an FCD develop here. And that FCD is developing along the line of action of that small link, okay? And so that's going to conclude this example. It's quite simple. If I were you, when we have a complex-looking system like this, I would maybe take some extra time and review that handout or that table that shows all those common type of connections for 2D rigid bodies, because that could come in handy, especially when we have kind of an interesting looking setup like this. Well, hopefully you found this video helpful. If you did, please hit like and subscribe and be on the lookout for other content like this. Thanks for watching.